So far we have worked with simple list that contains numbers or strings. In Python, lists can contain other lists, and that's what we call nested list. Let's look at an example, L underscore nested. You can think of it as a list of lists. Each small list inside is like a row of data. So in this structure, N and L underscore nested is our outer list because it holds other lists, and each 1, 2, 3, 4 and 5, 3 is an inner list. So if we access L underscore nested 0, we get a first inner list, that is 1, 2. But if we go one level deeper, that is L underscore nested, we supply two subscripts 0 and 1. That means we access the second element inside the inner list, which is 2. This kind of structure is very common when dealing with tabular data, matrices and multi-dimensional arrays. Visually, you can imagine a big container, that's outer list, holding several small containers, the inner list, each small one containing its own values. So understanding this structure is very essential before learning about the concepts of shallow and deep copies, because when you copy a nested list, you have to decide whether to duplicate just the outer container or all the inner ones as well. Now let's explore what happens when you try to copy or repeat lists in Python. At first glance it looks simple, but there is an important concept underneath that is called shallow versus deep copying, and it can lead to maybe confusing bugs if we do not understand it carefully. Let's start with a repetition example. Here we start with a is equals to 1, 2, 3. So this is stored at memory address 5000. When we create b is equals to a into static 3, the Python doesn't make 3 new lists. Instead, it creates one outer list at address 6000 containing 3 references pointing to the same inner list object at address 5000. So if we change a value inside one of those inner lists, say b0 of 0 is 99, all 3 will appear updated because they all point to the same memory object. Python's list repetition doesn't create new list, it repeats the references to the same underlying object. So in memory, all 3 elements of B are actually pointing to the same list object, A. When we print B, we see it looks like 3 separate lists, but they are actually all connected. Watch what happens if we modify just one sublist. For example, B0 of 0 is equals to 99. Now all 3 sublists show 99, 2, 3. That's because they are all referring to the same inner list in memory. This is why we say list repetition repeats references, not copies. Now let's move on to shallow versus deep copying concept, which gives us a better control. Python provides 2 main ways to copy object: shallow copy and deep copy. Shallow copy, which makes a new outer list but still references the same inner objects. Deep copy, which makes a completely independent clone, that is, both the outer and inner elements are duplicated. Let's see this in action. Suppose we have a list L1 containing 2 inner lists 1, 2 and 3, 4. We make a shallow copy using L1.copy and deep copy using copy.deepcopy. Now if we modify L1 of 0 is 99, then change affects both L1 and L2 because they share the same inner list. Shallow copy makes a new outer list but doesn't make new copies of the inner list. So here L1 and L2 have different outer list addresses, maybe 7000 and 7100, but both still references the same inner list, that is 7200 and 7300. So if you modify one of the inner lists through L1, that change also shows up in L2 because both share the same inner objects. So in contrast to this, deep copy duplicates everything. Python builds an entirely new outer list and recursively copies inner list too. So now L1 and L3 point to completely separate memory addresses, both inner and outer. That means modifying L0 of 0 will not affect L3 at all because their inner objects are independent copies. But L3, which was created using deep copy, remains completely unchanged. So shallow copy duplicates only one level of the object structure, and deep copy recursively duplicates everything inside. So deep copies take more memory and time, but they guarantee total independence between the original and the copy.